Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we see the problem number 9, which is based on principle of mathematical induction of chapter method of induction and binomial theorem. The problem number 9 is cos theta plus I sin theta whole bracket raise n is equal to cos of n theta plus I sin of n theta. So this we have to prove by using principle of mathematical induction. Now let's see the solution. First of all, the given problem we denote as a Pn. So let P of n equivalent to cos theta plus I sin theta whole bracket raise n equal to cos of n theta plus I sin n theta for all n belongs to set of natural number. Now here we consider step number 1. Put n equal to 1. So we get LHS is equal to cos theta plus I sin theta bracket raise n. Now for n we have to substitute 1. So the next step will be cos theta plus I sin theta whole bracket raise 1. So that gives us cos theta plus I sin theta. Now here we consider a right hand side. So RHS is equal to, we have cos of n theta plus I sin of n theta. Now for n we have to put 1. So the next step will be is equal to cos of 1 into theta plus I sin of 1 into theta is equal to, finally we get cos theta plus I sin theta. So in this way we proved left hand side is equal to right hand side, and therefore P of n is a true for n equal to 1. That is, P of 1 is true. Now here we consider step number 2. We consider that P of n is a true for n equal to k. That is, cos theta plus I sin theta whole bracket raise k is equal to cos of k theta plus I sin of k theta. Now let us this denote as a equation number 1. Now we consider the step number 3. Finally, we have to prove that P of n is a true for n equal to k plus 1. That is, cos theta plus I sin theta bracket raise k plus 1 is equal to cos of k plus 1 theta plus I sin of k plus 1 theta. So this we have to prove. So we start from left hand side. So LHS is equal to cos theta plus I sin theta whole bracket raise k plus 1. Now by using law of indices, this can be written as cos theta plus I sin theta raise k into cos theta plus I sin theta raise 1. Since a raise m plus n can be written as a raise m into a raise n. So the next step will be, now for cos theta plus I sin theta bracket raise k, so by using equation 1 we can write it as cos of k theta plus I sin of k theta into, we write second bracket that cos theta plus I sin theta, and in bracket we mention by using equation 1. So the next step will be is equal to cos k theta into cos theta plus I into sin theta into cos k theta plus I sin k theta into cos theta plus I square sin of k theta into sin theta. So the next step will be, we write cos k theta into cos theta as it is plus, from second and third we take I common. So in bracket we have sin theta into cos of k theta plus sin of k theta into cos theta. then plus. Now for I square, we write -1 into sine of k theta as it is and into sine theta as it is. Since I means root -1, therefore I square gives -1. So is equal to. Now here we combine first and last term. So we have cos of k theta into cos theta. Now plus minus minus sine of k theta into sine theta as a one bracket, and plus we write second bracket as it is, that is I in bracket sine theta into cos k theta plus sine of k theta into cos theta. So by applying trigonometric formula, that cos A cos B minus sin A sin B, so that gives us cos bracket A plus B. So similarly here we get cos bracket k theta plus theta, then plus I times. Now here for second bracket we use formula sin A cos B plus cos A sin B. So that can be written as sin in bracket A plus B. So in present case we write sin in bracket k theta plus theta. Now here we take theta common from each bracket. So we have is equal to cos in bracket k plus 1 into theta plus I sin k plus 1 into theta, and that is nothing but right hand side. So in this way we prove left hand side is equal to right hand side. It means we proved P of n is true for n equal to k plus 1. That is, P of k plus 1 is true. So in this way, by using principle of mathematical induction, the statement P of n is true for all n belongs to set of natural number. So this is a required solution for the given problem. Thank you.